Welcome to this video on reducing rational expressions. Let's get started. The directions tell us to simplify completely. Notice that our steps are to first factor the numerator and denominator separately. Then, step 2 is to identify all excluded values by setting the denominator equal to 0 and solving. Then we cancel out any common factors and write our simplified answer with a list of excluded values. So let's begin. Notice that we have two monomials, so we're not going to be doing any polynomial factoring. So you can approach this one of a few ways. One thing to think about is the numbers 27 and 12. One way to do this is to think about a prime factorization. So 27 is 9 times 3, and 9 is 3 times 3. So the prime factorization of 27 is 3 times 3 times 3. 12 is 3 times 4. And then 4 is 2 times 2, so 12 is 3 times 2 times 2. So if you don't want to go into this level of detail when you do your work, that's totally fine. I'm trying to be thorough so that you can completely understand this example, no matter what level you're at. Okay, so I can rewrite 27 x cubed y squared as 3 times 3 times 3. X cubed is x times x times x. Y squared is y times y. Okay, then let's go downstairs. So we have 3 times 2 times 2, that's 12. Then we have 1, 2, 3, 4, 5 x's and 1 y. Okay, so we have factored out the numerator and denominator separately. So before we get all excited and start canceling things out, the first thing we need to do is to identify our excluded values. Okay, so in other words, I have to set this denominator equal to 0, 12x to the 5th y equals 0, and solve it. Well, the only way that 12x to the 5th y equals 0 is either if x is equal to 0 or if y equals 0. So these are our two excluded values. So let's just write that over here. X can't be equal to 0 and y can't be equal to 0. We'll just make a note of that. Now let's go back to the original problem and start canceling things out. If we look at the numbers, we can see that there's a 3 upstairs and downstairs, and those both cancel out. If we look at the x's, we can see that 1, 2, 3 pairs of x's cancel out. And then if we look at the y's, we can see that 1 pair of y's cancels out. So what's left over? Well, 3 times 3 is 9. And then upstairs there is 1 y left over. Downstairs, 2 times 2 is 4. And then there are 2 x's, x times x, which is x squared, left over. Now, we're almost done. The last thing we need to make a note of is that x cannot be equal to 0 and y cannot be equal to 0. So this is our complete answer. And now we're done. Let's do another example. Once again, we have a monomial divided by a monomial. So if we want to factor out xy, well, we just write that as x times y. X squared is x times x, and then, of course, y to the 5th, we can write 5y's. Please notice that you don't have to do it this way. You can use the product, quotient, or power rule to add or subtract exponents. This is just the way that I'm going to demonstrate it so it makes sense. So we have one pair of x's that cancel out, and then we have a pair of y's. So you might be thinking, oh, there's nothing left in the numerator anymore, so the numerator is 0. However, that is not true. What is true is that there's always a 1 up here, even if it's invisible. So the numerator is not 0, but 1, so be careful with that. Okay, in the denominator, we have an x left over, and we have 4 y's. Now, again, we kind of got excited and we started canceling things out. We haven't yet done this step where we found our excluded values. Okay, so if I look at my denominator, remember x squared y to the 5th cannot be equal to 0. So what does that mean? Well, that means that x can't be equal to 0 and y cannot be equal to 0. Okay, so those are our two restricted values, and we're going to add those at the end of our answer. Okay, and that is our complete answer. So again, we wrote our simplified answer with a list of these excluded values. Oops, sorry about that. Okay, so don't forget this part over here. All right, let's do another example. Example 3. Okay, so this is fun. We're finally getting into polynomials. So x squared minus 25, you might notice, is a difference of squares. So that can be factored as x plus 5 times the quantity x minus 5. Okay, then we have a trinomial. Okay, so you can do this on your own, but x squared plus 7x plus 10 factors out into x plus 2 times x plus 5. Okay, so at this point you might get super excited and be like, oh my gosh, I see some factors that cancel out. The x plus 5s cancel out. Well, that's fine, but don't forget step number 2. That's super important. Okay, so the denominator, x plus 2 quantity times x plus 5, cannot be equal to 0. Okay, so that's really important. So we have two equations to solve. X plus 2 cannot be equal to 0, and x plus 5 cannot be equal to 0. Okay, so we subtract 2 from both sides on that equation, subtract 5 on both sides on that equation. So that means that x is not allowed to be equal to negative 2, and over here x is not allowed to be equal to negative 5. Okay, so when we write our final answer, right, we have x minus 5 quantity divided by x plus 2. Sorry, is that right? Yeah, x plus 2. Okay, comma, then we have to say x cannot be equal to either negative 2 or negative 5. Let me rewrite that. It looks kind of ugly. Okay, and that is my complete answer. Okay, so the important thing is that even though these terms canceled out, okay, they still generated a restricted value. And why is that? Well, that's really because, remember, 0 over 0 is still not 0, but is still undefined. Okay, so even though that term is gone, so algebraically it cancels out, it's still, the x plus 5 in the denominator still generates this extra restricted or excluded value. So please be careful with that. Sometimes students try to find the excluded values after they cancel out, and then you would miss that one. So be careful. All right, let's look at example 4. Okay, so we have 2x squared plus 19x minus 10 divided by 9x plus 90. So again, we get fun times. It looks like we are factoring a trinomial upstairs. So we're probably going to have to use that AC method that we learned. Okay. So A is 2, B is 19, C is negative 10. So AC is negative 20 and B is positive 19. So what does that mean? That means we need two numbers that multiply up to negative 20 and add up to 19. So 20 times negative 1 is negative 20, and then 20 plus negative 1, or 20 minus 1, is 19. So that's going to work. Now remember, when A is not 1, we can't use that shortcut method like we did in a previous problem. So what does that mean? Well, that means we have to use the long method, which is factoring by grouping. So we have 2x squared plus 19x minus 10. Okay, so then we rewrite 19x as the sum of plus 20. Well, let's rewrite it. Let's write the subtraction first. That'll make it easier. So let's do minus 1x and plus 20x. Okay, so then we'll bring down 2x squared and minus 10. Okay, so from here we can do our grouping like we do. Okay, and then we can factor out an x here. So we have x times the quantity 2x minus 1, and then we have a 10 that we can factor over here, and we get 2x minus 1. Okay, so remember, the magic happens if and only if these two terms are the same, which they are. Okay, so we can factor out 2x minus 1, and then what's left over is the x plus 10. So all of that work was just to factor out the numerator. Okay, so now let's look really quickly at the denominator. So we have 9x plus 90. Okay, so this is a binomial. There are two terms. So what can we factor out? Hopefully you can see we can factor out a 9. So we have 9 times the quantity x plus 10. Okay, so I'm going to draw some lines here because this is getting a little bit full and I don't want to confuse anybody. Okay, so over here I'm going to put this all together. So the factored form of the numerator is 2x minus 1 times the quantity x plus 10. Okay, and the factored form of the denominator is 9 times the quantity x plus 10. Okay, so as you probably anticipate, there are some restricted values, or sorry, we can cancel something out. All right, but first we have to think about what are our restricted or excluded values. Okay, and very simply, 9 times the quantity x plus 10 cannot be equal to 0. Okay, 9 cannot be equal to 0. Well, that's not a problem. 9 is never going to be equal to 0 because 9 is just 9, right? And then we have x plus 10 can't be equal to 0. Oops, not 10. So we subtract 10 from both sides, and we have that x cannot be equal to negative 10. Okay, so going back to this, you probably saw that these do cancel out, and I'm kind of out of room here. So let me go back and erase this part here so I have some room to write my final answer. Okay, remember, if I go too fast, you can always pause the video. Okay, so my final answer is 2x minus 1 over 9, right, comma, I have to make a note that x cannot be equal to negative 10. Okay, because even though algebraically I can eliminate those two terms, right, graphically that function is going to have a hole in it. It is going to be undefined at x equals negative 10. Okay. All right, let's do another problem. So this time we have x cubed plus 64 divided by the quantity x squared minus 16. So the numerator is a perfect cube, and I took the liberty of writing out the way to factor that here. So let's break this down. So x cubed is x cubed. 64 is something cubed. Well, in case you forgot, 64 is 4 to the 4th power. Okay, so that basically means that x is x and y is equal to 4. Okay, so I'll just write that down here. So x is just x, y is 4 in this formula. Okay, so instead of y, I'm going to write the number 4. This is a 4, and then this is x squared minus 4x plus 4 quantity squared. Okay, so that's x plus 4 times x squared minus 4x plus 16. Okay, so that is the factored form of the numerator. Okay, so let's look at the denominator. Let's try to factor x squared minus 16. You might realize that that is a difference of squares. So it's x plus 4 times x minus 4. Okay, and then remember, neither of these things are allowed to equal 0. So let's go ahead and do step 2, where we are figuring out our excluded values. Okay, so x plus 4 can't be equal to 0. X minus 4 can't be equal to 0. Okay, so x can't be equal to negative 4, and x cannot be equal to positive 4. Okay, so let's put this all together. Okay, so the factored form of the numerator, we said, is right here. This is the factored form of the numerator. Okay, so that is x plus 4 times the quantity x squared minus 4x plus 16. Okay, the factored form of the denominator is right here. So we'll rewrite that down here. So that's going to be x plus 4 times the quantity x minus 4. Okay, and then we have our restricted values, which are minus 4 and plus 4. Okay, let's cancel our terms out first. Notice that the x plus 4's cancel out. So that leaves us with x squared minus 4x plus 16 divided by the quantity x minus 4. And then I write a comma here and make a note that x cannot be equal to 4 or negative 4. Okay, and that is our final answer.